Hello everyone. This is the first lecture of a new series of lectures on protein. And fittingly, we're going to start off with what determines the quality of a protein. So, one of the things to know is that proteins provide the building blocks of muscle. Also know that athletes need 50 to 175% greater needs than sedentary individuals. In addition, a lot of research has been done on different types of proteins like milk and plant. What we're going to do is focus on which of these is ideal. So, one of the key concepts that you want to know is that protein quality is determined by the essential amino acid content of the protein. So if you look here, you see fasting levels of protein synthesis. You see that protein synthesis goes up with a whole protein, but then you see it goes up equally with an essential amino acid mixture. However, with the non-essential amino acids, it doesn't go up at all. This indicates that what's driving the protein synthetic response is the essential amino acids. So, a complete protein are those proteins which contain all of the essential amino acids, and that includes things like meat, eggs, dairy-based products. Those that are incomplete or lack more than one of the essential amino acids are things like beans, wheat-based proteins, in general, any plant-based protein. So there's a really cool study that was done by Campbell, and he had individuals resistance trained for 12 weeks. One group was placed on an omnivorous or meat-eating diet, and another group was placed on a vegetarian diet, but it was protein matched, so no differences in protein between conditions. This is what happened. The omnivorous group went up in lean mass, vegetarian group went down. And the opposite happened for fat mass. Now, I don't know about you, but I'd be pissed off if that's what happened to me. So what it shows is that if you're going to train hard, you need substrate to repair skeletal muscle. So going to plant versus dairy, obviously meat's better than plant. Let's talk about dairy versus plant. Soy is often used as an alternative to meat because it's a complete protein. However, it is still low in the essential amino acids. So what you have here is looking at change in plasma amino acids after consuming carbohydrate, whey, or soy. This is the whey group. Notice essential amino acids spike really high. That is the soy group. Okay? It's a little bit higher than the carbohydrate group. Remember, essential amino acids drive the response. This graph is looking at change in lean mass. And what I want you to notice is that the carb group to the left and the soy group to the right, there's no differences between those two. However, it's clear that the whey protein group got the best gains. So, take-home messages, whey protein or dairy, if it was a dairy protein, it was higher essential amino acids, drove lean body mass changes. One of the things that was interesting is if you look at testosterone levels, essentially, minutes after training, you see the whey protein isolate is the black, soy protein isolate is the gray or light gray, and then the carbohydrates is the dark gray. So if you look at pre-total testosterone levels to mid, to post-exercise, the soy sort of drops the total testosterone. And this is something that's really interesting. Soy seems to contain certain properties like phytoestrogens, which may actually lower testosterone. So it's not something that you necessarily want to take with your workout. It doesn't have much benefit. And in addition to that, it may have some negative outcomes. So if you look at all the essential amino acids, the real question becomes, which essential amino acid drives protein synthesis? Because there's 9 essential amino acids. Well, this classic study by Garlick, I'm sure many of you have heard of the branched chain amino acids. So you look at protein synthesis with just glucose plus a whole protein, glucose minus complete protein minus the branched chain amino acids, and then just the branched chain amino acids and glucose. Notice the branched chain amino acids stimulate as much protein synthesis as the complete. When we look to the graph on the right, they line up the 3 branched chain amino acids, which are leucine, valine, and isoleucine, and you clearly see that leucine is driving the response. So we can say that leucine is the trigger for skeletal muscle protein synthesis. So here's some work from my brother Gabe and Lane Norton at a Dr. Lehman's lab. And basically what they did is that they looked at the effects of feeding. They gave 16% protein diets, and they looked at protein synthesis with equal servings of protein of wheat, egg, and whey. You see wheat 7% leucine, eggs 9%, whey 11%. Notice that the egg and whey are higher than the wheat. Also, at the end of the study, the egg and whey had more muscle mass in their calf muscles, the gastrocnemius, than the wheat. So there's a real good concept. One of the things I'm sure you've read in your textbooks that, my textbook says I only need 0.8 grams of protein per kilogram of body weight. Well, what's that based on? It's based on this concept here, where if you look here, you're looking at this graph, it's oxidation, okay? After 0.8 grams per kilogram, you see the amino acids get oxidized at a much higher rate. This led scientists to believe, incorrectly, that essentially they weren't being used for anything other than building blocks. But we know amino acids also play a signaling role. So that spike in oxidation and amino acid appearance appears to be the trigger for skeletal muscle protein synthesis. So here to the left group, we see serum leucine levels at saline 5% and 10%. Notice 10% you have a sharp rise, and everything after that sharply increased. That's what triggers protein synthesis. Okay, so this sharp rise in amino acids is what triggers the response, as we can see here. So this is a study actually my brother Gabriel headed up, and what they did was they gave a fasted condition, a wheat condition, and then a whey condition. You see the whey stimulated protein synthesis. Gabe then added leucine to wheat, and it restated protein synthesis, again supporting the role of leucine for protein quality. So how much leucine do you need? This is a study by Moore in 2009, and they looked at 0, 10, 20, 30, and 40 grams of protein, and that's equivalent to like 0.5, 1, 2, and then 4 grams of leucine. Notice that protein synthesis peaks and starts to plateau at around 2 grams of leucine or 20 grams of high-quality protein. Though, if you're a bodybuilder, you're looking at that 40-gram dose and saying, oh, those extra little spike in protein synthesis could be beneficial. Now, in this study by Pastiakos, they gave essentially amino acids or amino acids, or essential amino acids, are essential amino acids with a bumped up leucine content. And it was real interesting what they found. It was really interesting what they found. They found that 3.5 grams of leucine stimulate more protein synthesis than 2 grams of leucine. Here, we see that 7% greater increases in protein synthesis with 40 versus 20 grams with whey. So whey 56% and 20 grams of whey 49%, but that wasn't statistically different. But again, as a practitioner, you need to ask yourself, is that 7% worth it? I think a lot of athletes would say it is. This is looking at what we call the leucine threshold. You notice that protein synthesis peaks at around 2 to 3 grams of leucine. So therefore, you could choose your protein source based on the leucine content. Whey's 11% leucine, you may only need 17 to 25 grams. Beef, however, you may need 25 to 36 grams. And we can see that here. Egg, which has a higher leucine content, plateaus at around 20 grams. However, beef does not peak until 36 grams, which you can see on the left. And here we see essentially a nice relationship between plasma leucine levels following protein consumption and lean body mass changes. So basically, again, protein quality is determined by essential amino acid content, particularly essential amino acid leucine. And so that's very, very important to know. You need about 2 to 3 grams of leucine per kilogram. That's going to depend on what protein source you consume. Thank you. I look forward to talking to you soon.